Good morning, everybody. Welcome to a wonderful morning of Chem 1211 with your host, me, Dr. White. I hope you all had a nice Thanksgiving weekend. Boy, did I ever, oh, did I ever. Turkey wasn't the only thing that got stuffed Thanksgiving dinner. But anyways, because of that and other things, boy, my weekend was really busy. So I have to apologize. I didn't get to grade the lab you did on last week and hand it in. Fix my hair. But anyways, I sent out an email which has a mistake in it, but by this Wednesday morning, I will have graded all the labs that you have handed in. And if you look in Blackboard and you don't see a score, email me, because I didn't grade it. Maybe you handed it in late, whatever. Email me and we'll resolve it, because students should never, ever be penalized by a mistake I make. And guess what? Once in a while, I do make mistakes, not intentionally. All right, another thing, I did make a mistake, but anyways, the email is sent out. I said the deadline for the extra credit was this Wednesday. No, it's a week from this Wednesday. It's 12/7/22, December 7th is the deadline for the extra credit. Remember, it's 10 eye-popping points that if you do it, and if you send it to me, email it to me before you hand it in, I'll check it over. If there are any mistakes, I'll tell you about it and help you correct it. So you should be able to get 10 points. All right. Now, let me remind you, and a game plan for today. Let me do that first. Announcements, and I'll be doing that now after I finish this. Next, I'll go through quiz 5 answers, which I'll cut out of the video. I like my special effects. Hold on. No, it doesn't work as well with my thumb down. But anyways, I'll cut that out of the video. I'll go through quiz 5 answers. Then remember, this Wednesday, I'll be giving online quiz 6. And today I'll do the review for quiz 6. And I will also go through the problem set today on pH. I also uploaded the last lab. Oh, the semester's almost gone. Isn't that sad? But anyways, the last lab, which I wrote because we don't have any more Carolina labs, and I wanted to include 1 or 2 more, and I did. And this one, come tomorrow and you'll find out what it is. It deals with some very dangerous chemicals. All right, let's go through important announcements. And everybody should see the quiz 6 important announcement. I will be giving quiz 6 on this Wednesday at 11 a.m. or maybe a couple minutes sooner. At that time, I will be emailing you the password for quiz 6. You'll have until when? That's a mistake. It should be until Thursday morning. Wow. I've got to start taking my no mistake pills. But anyways, you'll have until I'll correct this Thursday morning, 12/11/22 at 11 a.m. to take quiz 6 and upload your answers as a single PDF file. I reserve the right to subtract 25 points from your total for anybody who doesn't follow instructions and doesn't upload your quiz 6 as a single PDF file. Now, quiz 6 has 6 pages, 10 problems, including multiple part questions, but no multiple choice questions. It's worth 55 points. So there's 5 bonus points. The way I do bonus points, I just have the whole thing add up to 55 instead of 50. and therefore you can pick whatever the bonus points are. I don't. Now, it will cover Chapter 14, which includes Bronsted-Lowry acids, Bronsted-Lowry bases, chemical formulas of key acids and bases, what is a conjugate base and acid or acid base and how to identify it, the water dissociation reaction, the ionization constant of water, Kw, not named after me, shucks. But anyways, what's an acidic solution? What's a basic solution? What's the neutral solution? The pH concept, pH determination calculations, buffers, and titrations. Wow, that's a list. But anyways, this probably chapter 14 is probably the most important area for you for the rest of your life. All right, now, as always, I recommend you download the PDF file, which will be available to you tomorrow after 9 a.m., I think, or 8 a.m. By this Sunday, 1 p.m. or earlier, hopefully earlier, I will have your scores posted on Blackboard. I'll send out an email to that extent. And also by that Sunday, this Sunday or earlier, hopefully earlier, I will send out your individual points for each answer on quiz 6. And next Monday, a week from today, I'll go through quiz 6 answers. But like today, I'll cut it off. Now, let me go through a mistake I made and correct it. This reminder, the extra credit point project 10, 10, 5, and 5 is 10 points, bonus points, think of. And I had an email I sent out today, I had it wrong, and I'll correct it later today, is due December 7th, and no late projects accepted. So between now and next Tuesday or Monday, email me your project before you upload it to Blackboard. I'll check it. If there's anything wrong, I'll let you know and help you fix it. So that way you can get 10 bonus points. All right, any questions about quiz 6? Well, in that case, I better get to work. All right, everybody should see quiz 5 key on your screen right now. Thumbs up, people. Thank you, Brianna, and Gianna too, W, and everybody else. All right, this person Key always gets great scores on my quizzes and tests. Don't know why. By the way, in case you've never seen it before, which you should have, this is my monogram KW. That's a K inside of a W. And I spent my whole first semester, non-Western civilization in high school, being bored out of my mind. So I came up with a challenge, come up with a monogram, and I've been using it ever since. Oh, I aced that course. All right, let's go through the key. And remember, check your quiz, check the answer, the points I sent you in the email. Make sure I did not make a mistake grading. Students should never, ever be penalized for a mistake I make grading. All right, let's go through this. All right, 3 points. And make sure for each one, if it was a 3-point and it was correct, I gave you 3 points. Or if it was a 4-point, I mistakenly gave you 3, you should check that. All right. Now, and on these, I gave sometimes partial credit if it was partially right. All right, briefly explain what the activation energy for a chemical reaction is, and it is the minimum energy needed for a reaction to occur. Or you could have put the amount of energy for a collision to have a reaction occur. All right, please explain one aspect of the collision theory for chemical reaction. And there are 3 of them, but you only have to put down one. One, reactant molecules must collide. Collisions must have enough energy for the collision to cause a reaction, for it to react, otherwise known as EACT, or the activation energy. And molecules have to have proper orientation. Again, you only need one of those three. Next one, name one factor that can affect the rate of a chemical reaction. And one of them is the state of the reactants. The other is concentration of the reactants, and the reactant temperature. I guess you also could have put down, which I didn't on the key, but it would be acceptable, a catalyst. Now, this is important. I have underlined. How does a catalyst work? I did not ask what is a catalyst. If you answered what is a catalyst, I gave you 0 points. All right, how does it work? It lowers the activation energy, EACT. And remember, while I'm going through this quiz, if you have any questions, ask. Because like I said the first day, and I'll say it the last day, and it's always true in my life, there's no such thing as a dumb question. All right, next 6 points. To make sure I did give you 6 points, write the equilibrium constant for the following reaction, and equilibrium KEQ, and you don't have to put this down, but it's the concentration of each product to the power of the coefficient of that product divided by the concentration of each reactant to the power of the coefficient. So for potassium chloride, KCl is bracket KCl squared times, and good news, since I told everybody, common mistake, students put a plus there. Nobody did this semester. Thank you. And then times oxygen to the Q power divided by potassium chloride, KClO3, to the second power. Oh, by the way, interesting thing, KClO3 is solid rocket fuel. It's used by the military. All right, let's move on. And here a number of you had problems. And before I go through this, let me give you some advice. My test 2, don't tell anybody, is essentially my final. Even though the department gives an ACS final, I give a test 2 to cover that, because the ACS final, well, not that good. But it's only worth 15 points, 5, 5, and 5. I've done that. But a lot of you had problems on Le Chatelier's principle. On test 2, I promised myself, and I've never broken a promise to myself, there will be a Le Chatelier's problem on there. So make sure you know how to do this. Let's go through that. All right. You're given an equilibrium. How do you know it's an equilibrium? Double-headed arrows. It's carbon monoxide plus 3 moles of hydrogen gas give methane CH4, water, H2O, I hope you all know that by now, and heat. This is an exothermic reaction. Describe what will happen to the concentration of CO, carbon monoxide, when you put the reaction in ice bath. Now, ice bath removes heat, and the stress is heat was removed. Oh no, we've got to make more heat. How do you make more heat? CO, carbon monoxide, reacts with hydrogen gas to shift it to the right to make more heat, and methane and water. So if CO is reacting, it's consumed. Remember the cookie? You consume some of the cookie. How much do you have in your hand? More or less? And the answer is less, and the concentration decreases. All right, let's go to B. What happens to the water concentration when you add carbon monoxide to the reaction? Well, at equilibrium, there was a certain amount of CO. Now there's, oh no, too much. How do we get rid of the excess CO, carbon monoxide? Well, it reacts with hydrogen to make more methane, CH4, water, and heat. Well, if I'm making more water, the concentration will increase. Next, describe what will happen to the methane, CH4, concentration when you add water. Well, here's the water. At equilibrium, there was a certain amount of water. When I've added more water, oh no, there's too much water. How do I get rid of the excess water? There's only one way. Water reacts with heat and methane to shift the equilibrium this way to the left to make more CO and hydrogen. Since water is reacting with methane, the amount is consumed, some of it. When something is consumed, reacted, the amount decreases. What will happen to the hydrogen concentration when you put the reaction in boiling water? Well, when I put it in boiling water, we're adding heat. Now there's too much heat. Oh no, we've got too much heat. What do? Well, I react the heat with the water and methane, CH4, to shift the equilibrium to the left to make more hydrogen and CO. If I'm making more of something, the amount you have increases. Next, I asked you to draw the energy diagram. Because it's exothermic, heat is given off. The energy on this side is equal to the energy on the right side. And because heat is given off, the energy of methane, CH4, and water, H2O, is going to be less than the energy of CO and hydrogen. And notice I have it lower because it's less. Now, it starts here, goes over the hill and down the hill to grandmother's house, so you go, no, to the methane and water. And that y-axis has energy, x-axis time. And from where you start to the top of the hill is the activation energy, E-act. All right. If you didn't have E-act, I took off a point. I forgot how many points if you didn't have the methane and water lower than the CO and hydrogen. And you could have put products and reactants, that was okay. All right, 7. Given the following equilibrium, K equilibrium 1.0 times 10 to the 20th for this reaction, describe the relative amount of concentration of phosphorus pentachloride, nasty stuff, I've worked with it, as compared to concentration of chlorine gas. And I've worked with that too, nasty stuff. And since K equilibrium 10 to the 20th is much, much greater than 1, you know 3 dots means therefore products are much greater than the reactant concentration. Therefore, PCl5 is going to be much greater than Cl2. Now, make sure I gave you 4 points. If you did this right, describe a key fact about the forward and reverse rate of reaction for this chemical reaction when chemical equilibrium is reached. And the answer is always a chemical equilibrium at equilibrium has the same forward and reverse rate of reaction. In other words, they're the same. Now, what happens to the rate of a chemical reaction when you increase the temperature by 10 degrees? And the answer is it doubles. I think I gave 1 point if you just said it goes faster or gets higher, because it doubles. All right, the last one, a lot of you had trouble with. Listen closely, watch closely. You have this equilibrium. Cobalt tetrachloride, COCl4 minus 2 with 6 waters is equilibrium with cobalt hexahydrate, COH2O6 plus 2 plus chloride minus and heat. And I asked what happens to the color of the solution if 1A adds a lot of water. You got two choices, red or blue. And when you add water at equilibrium, there was a certain amount of water. Now there's too much. Oh no, too much water. How do you get rid of the excess water? Water reacts with the cobalt CO tetrachloride anion, COCl4 minus 2, to make more of the COH2O6 plus 2, which is red, a lot more. Therefore, it's going to shift to the right and the color will be red. Now, put the reaction in a beaker of hot water. Hot water adds heat. At equilibrium, there was a certain amount of heat. Now you have too much heat. How do we get rid of the excess heat? Oh no, too much heat. This chloride anion reacts with this cobalt hexahydrate COH2O6 to make more water and more COCl4, cobalt tetrachloride anion, which is blue. So it's going to shift it to the left and the color will be blue. Now, we don't do it in the home kit, but in the lab at COD face-to-face, we do this equilibrium. And when you do this, it shifts it to that colors. Like I said, a lot of you got this wrong, and you should learn how to do this. Remember, on Tuesday and Thursdays, I have my office hour. Now, I was busy this morning. I apologize. I forgot to do the calculations to figure out how to figure your current grade. Tomorrow, I'll do that at the beginning of the lecture lab, and I will not cut that out of the video. But I can tell you this, just for this quiz alone, if you got 45 and above, you were getting an A. Let's see, 50 times, if you got 40 and above, that was a B, 35 and above, C, and 30 above, D, below 30, F. I think most of you did that, but a lot of you were a little lower score. But when I give this kind of quiz or these questions, students have trouble with it, which a lot of you did. Remember, I promised myself on test 2, there will be a multi-point Le Chatelier's question. All right, any questions about that? All right, let's move on. To quiz 6 review. Everybody see quiz 6 on their screen? Thumbs up, people. Thank you, everybody. All right, let's go through this. And these are things you should know for quiz 6. That is this Wednesday. And first of all, you should know, what is a Bronsted-Lowry acid? It's a proton donor. Notice I have it in red. I put something in red, that's important. What's a Bronsted-Lowry base? It's any substance that accepts the proton. Remember, a proton is H+. So a Bronsted-Lowry base is a proton acceptor. If I'm a Bronsted-Lowry acid and I see a question, go for it. My speaker's on. Jasmine? Jasmine, do you have a question?
Oh, no, I'm sorry. That's a mistake.
Oh, okay. If
Thank you.
go right ahead and ask it.
No, it was a mistake. I just
Never
raised it by
mind.
accident.
Guess what? That happens. That's allowed in my class. I make mistakes too. All right, let's move on. Once again, you should know a bronzed acid, proton donor. Here, take my proton. I'm an acid. And a bronzed base is a proton acceptor. Give me your proton. Give me your H plus. I'm a bronzed base. All right. Next, you should know HCl, H2SO4, HNO3 are acids. If I ask, and you'll see this in the problem set we'll do later to the morning, HCl, is that an acid, base, or salt? And the answer is acid. Same thing for H2SO4, sulfuric acid, and HNO3, nitric acid.
Do we have to know the names or just we have to know that it's acid?
You just have to know it's acid.
Okay, thanks.
You're welcome. Next, bases, NaOH, KOH, NH3. And there's one base I missed, so I better put it on here. Bad, Dr. White. And this one you should know. This is sodium bicarbonate. And you know it is baking powder. And this is baking powder. And you should know the formula, NaHCO3, and its name, sodium bicarbonate. Why? It's in most of your kitchens. These other things are not in your kitchen. They better not. Well, I'll talk about something later. All right, let's continue on with this review. Now, water can dissociate and it reacts with itself in an equilibrium that's mostly to the left. And you form, when it does go to right, H3O plus, the hydronium ion, and OH minus. And therefore, chemists have created what's called the ionization constant for water, Kw, my initials. See, I was destined to be a chemist. But you should know that's the hydronium ion concentration times the hydroxide equals 1, actually on the key, and I keep on forgetting to change it, 1.0 times 10 to the minus 14. Now, this is only true at 25 degrees C, but everything we'll do in this class for this is at 25 degrees C. Now, you should know what is an acidic, basic, and neutral solution. And here, and I'll write it this way, when the hydronium ion concentration is greater than the hydroxide, that's called an acidic solution. When the hydroxide ion, OH minus, is greater than the hydronium ion concentration, H3O plus, then this is called a basic solution. And a neutral solution is when the hydronium ion concentration is equal to the hydroxide ion concentration. And I should point out that acidic solutions that are safe to taste sour. What do I mean by that? Example would be lemons and limes. I would recommend you remember that, know that. Hold on. And you should know what are acidic, basic, and neutral solutions. And I'd highly recommend that acidic solutions taste sour. And examples would be lemons and limes. You ever bit into a lime or a lemon? You go, ooh, that's sour. That's because it's acidic. There's acid present. Citric acid. All right, let's go through this again. Basic solutions. Hydronium ion greater than the hydroxide, or H3O plus greater than OH concentration. Basic solutions, OH minus hydroxide ion concentration greater than hydronium or H3O plus concentration. Neutral solution, hydronium ion concentration equal to hydroxide. Boy, this pH stuff is thirsty work. All right, let's move on. Now, because this is time consuming and not easy, well, is this greater than this or less than? Someone came up, one of these days I'll have to find out who, the pH constant. And the pH scale is a scale of small numbers. And I'll never ask on a test or a quiz, what is the pH scale? But you should know this concept, and I'll explain why. It's a small number scale of small numbers that's used to specify the molar hydronium ion concentration of a solution. And the way it does it is right here, pH equal minus the log of the hydronium ion concentration, H3O plus. Remember, when it's in brackets, that means molarity, molar concentration. Now, remember, keep this a secret. Shh. My gift to you is if the hydronium ion concentration is 1.0 times 10 to the minus X, then pH is X. That way, because I'm lazy now, making it easier for you, you don't have to learn how to use the, where is it on here? Right over here, the logarithm function on your calculator. And also don't forget to multiply it by -1, which students do when I've done this on a test. So I've come up with my gift. When the hydronium ion concentration is 1.0 times 10 to the minus X, pH is equal to X. Now, one thing I'll show you in a little while, there's certain things for this chapter and quiz you need to memorize. Why? It's something you will use the rest of your life. And that's the pH scale. Notice I even have important. Here, let me stress it even more. You should know this. The pH scale goes from 0 to 14. At 7, halfway between, that's neutral solution. When it's above 7, it's basic. When it's below 7, it's acidic. Again, it's 0 to 14. The lower the pH, the more acidic. The higher the pH above 7, the more basic. And I put down this note, this is a logarithmic scale. So each one pH change is actually a power 10 change in the hydronium ion concentration. Now, if I were to say the pH of your stomach is about 1, and what's the Chem 1211 reason for that? And that's because there's acid present. It's acidic. Your stomach has a pH less than 7, pH 1, because your stomach has acid in there. time for a personal thing. I don't know why, but I think it's one of the great miracles of life that I have and you have in your stomach cells that manufacture hydrochloric acid. Boy, it boggles my mind. See, it's getting boggled. But anyways, there are a lot of other things that boggle my mind, but I'm not going to that long list. But the chemistry going on in your body is amazing and fantastic. I don't know if I told you, the greatest chemist of all is Mother Nature. Just look at your body, look at plants, all the chemistry going around you, going on around you. But remember, in your stomach, you have cells that make HCl, hydrochloric acid, and that's why the pH of your stomach is low. Now, that's the Chem 1211 reason, which is also for any other class. But what's the reason? Why does she do that, Mother Nature? Because that helps break down your food, but that's, I teach in 1212, not 1211, the chemical reactions, organic chemistry. Remember, I'm an organic chemist. Biased, aren't I? All right. So this is probably the most important thing I will teach you this semester, based on something useful you can use the rest of your life. And again, that's the pH scale. Below 7, acidic. At 7, pH 7, neutral. Above 7, pH is basic. Now, I talked about buffers. Buffers are solution that resist major changes in pH when small amounts of acid or base are added to it. Your blood is buffered to keep it in a very narrow range pH. If you add a lot of acid to your base to your blood, it will kill you. But small amounts that get in there are buffered because it's a buffer solution. Now, I'll talk more about titrations and buffers when we do later on today the problem set. For this chapter. Finally, titrations. Titrations are when you do an acid-base reaction. Now, if you have an acid or base of unknown molarity, concentration, if you add enough acid or base to the one you don't know acid or base, at neutralization, that's when pH for this class is equal 7. That means an indicator, pH indicator, changes color. At that point, you know, because neutral pH 7, moles of acid equals moles of base. And for this class, I simplified the calculation for a monoprotic acid, which means only one proton to give up. Some acids have more than one, but in this class, I'm going to stick to monoprotic. At that point, we know mils of acid times molarity of acid equals milliliters of base times molarity of base. And this type of titration, you'll always be given the milliliters of acid and the milliliters of base. Then one of these two, you'll be given milliliters of acid, molarity acid or molarity of base, and the other you'll solve for, molarity of acid, molarity of base, using this equation. And we'll do that in the problem set. All right, hold on while I find something I just closed that I shouldn't have. There it is. Everybody see important information on your screen? No, you don't. All right, now do you see it? Thank you, Brianna, and everybody else. Gianna W. All right, let's go through this. This will be given to you for quiz 6. pH equal minus the log of the hydronium ion concentration, and then my special gift. If H3O is 1.0 times 10 to the minus X, then pH equal X. I'll give you the ionization constant, hydronium ion times hydroxide, and I should have here, I believe I've corrected it on the quiz, 1.0 times 10 to the minus 14. And I give you, for titrations at neutralization, moles of acid equals moles of base. And also milliliters of acid times molarity of acid equals milliliters of base times molarity of base. Everything else I just went through in the review, you have to memorize, put in your head. But that's because this is important stuff that I want you or would like you to know for the rest of your life. And that's why I'm asking you to memorize it. I like my new memorization emoji. Does this work? Memorize. I don't know. But anyways, it got the point across. Any questions about quiz 6? All right, if I look at the clock, let's take a 5-minute break now. Come back at 9 in 5 minutes by my clock. That would be 9:50, 9:51. And I'm gonna get up and stretch. I'll see you in 5. Time to get going. All right, before we do the problem set, there are a couple of personal things I'd like to show you. But let me just close some things here first. One more thing to close. All right. Back when I was about 5 or 6, that's a long time ago. When I was a child, the big thing in the United States was the space race. And we were in a competition with the evil Soviet Empire, mainly Russia, which we're still in competition in certain ways. But anyways, because of that, everything toy related for little boys was rocket ships and space related. Now, I better warn you. Warning, warning, I'm going to be doing some artwork. So don't hurt yourself when you laugh too hard, because my mother was a very good amateur artist. My father was a very good amateur carving artist or carver. He did some beautiful stuff, so did she. And not one iota rubbed off on me, none. But anyways, I'm going to do some artwork, so warning. Now, when I was a boy, about 5 or 6, there was this candy that was sold in a little plastic tube that had a cap that had fins on it. Wow, this is a better one of mine. Inside were these little dots of candy. They're little spheres. And this was a rocket ship. Don't laugh too hard, please. But anyways, that was the worst candy in the world. How could you tell it was worse? Well, me and my friends, when we'd buy one of these, I think each one of these were a penny. So they're easy to come by. Still, a penny then was worth a lot more than a penny now, but it was still very inexpensive. And I can still remember, you get one of those and the candy was so awful, and you can tell it's awful, you'd take the tube off and dump it in the trash can and then play with the rocket. Now, my father, being a pharmacist who loved chemistry, why did I become a chemist? I don't know. But anyways, if you took this tube off and inverted it, you had a little test tube. And in this test tube, you could put some vinegar and baking powder. And I should have talked about this. I don't think I did when you did the airbag experiment, but vinegar is an acid. Baking powder is sodium bicarbonate. And this reacts acid base. It's a neutralization to give off salt. This is a salt, sodium acetate in this reaction, plus water, plus, and here's the important part, carbon dioxide given off as a gas. That's what the arrow up means. And so if you took this, put the two things together in there, slam the cap back on, again, don't laugh too hard, and you had the stuff, and all of a sudden you're building up CO2, the top would go flying off. If your timing was good, you hold that, you put it, shake it, hold it, slam the cap, hold it, and it goes boom. Didn't go boom, one pop. But anyways, it would fly about 4, 5, 6 feet off. If you're 5 or 6 years old, That's a really cool thing. My father was really cool. My friends all thought he was cool too. But anyways, we all started doing that. But I have to warn you, my best friend at the time, Dickie Gale, and we lost contact decades ago when he moved out of state. But anyways, he and his brother started doing that and used up all his mother's baking powder. And when she went to, they didn't tell her, and when she went to some baking, she reached for the baking powder, opened it up, it's empty. Boy, did Dickie catch it bad. Oh, you don't want to know. You got a whooping for that. So don't use up all your mother's baking powder, but you saw how to do that with the airbag, but that made it a great toy for kids. Now, I'm surprised with those things flying off, not that much, that nobody lost an eye. Well, we didn't aim at each other. We were nice. All right, now another thing I like to teach you that again, my father taught me. And that is how to make the best spaghetti sauce. Now, one of the things when I was young, my father owned a drugstore, pharmacist, and he was rarely home except on Sundays because he was at his drugstore Monday through Saturday. And when he came home, he was tired. Well, on Sunday, and my mother was a good cook. My father was a better cook. She was real good. He was really good. And sometimes on Sundays, and we had a big, deep chest freezer. I have a stand-up now, which we would put stuff in there, and he'd make a lot, or my mother would too, and then we'd pull it out the night before. This was before microwave. Now I just microwave it and let it thaw out, and that would be dinner. And one of the things he liked to make was spaghetti sauce. And we'd make about 3-gallon big pot, and I still now have a big pot to make large amounts of chicken soup and spaghetti sauce and other things. And what he learned, being a good person who liked chemists, that in tomatoes, there's citric acid. And the citric acid makes it taste sharp to you. But at the end, with a big pot, he'd put in about a tablespoon or a tablespoon and a half. Remember, I'm talking 3 gallons of baking powder. And what that did was neutralize some of the acid in there. If you add the baking powder to the tomato sauce, you'd form a salt, in this case, sodium citrate, which is safe, plus water, plus carbon dioxide, which was given off as a gas, and you see like a white foam on top of that would dissipate after a while. And what this did is by adding this base, sodium bicarbonate, the pH would go up a little, and that would make it taste milder. So by adding not a lot, but a small amount to a large amount, and it would make it milder because you've neutralized, reacted some of the acid, HA, citric acid in the tomato sauce. And we would take whole tomatoes that we would put in a grinder to make some of the sauce. And we'd also use the tomato paste from a can. And we'd have in there seasoning, onions, garlic, pepper, salt, oregano. Yeah, he used oregano. But one secret, and I've never asked him where did he learn. I can't now because he's been dead for a long time, unfortunately. But at the very end, with a big pot, he put a small, like a quarter teaspoon of cinnamon. If you've ever made your own spaghetti sauce, it doesn't taste like the stuff you get at the really good Italian restaurants in Chicagoland. That's because you don't know the secret. At the very end, they put in just a little bit of cinnamon, very little. Now, I had a friend of mine who was making 3 gallons. He was making a small pot. And he put in a tablespoon, a tablespoon, and he called me up the next day and said, well, I followed your recipe and it just tastes like cinnamon. I said, how much you put in? A tablespoon. How much did you make? Oh, about a quarter. Oh, you put too much, just a pinch, but it gives it that extra. Now, true story. In a class a couple of years ago, I think it was actually, I teach the story in my 12-12 class. One of my students, a couple of weeks afterward, came to me and said, thank you for your recipe, your father's recipe for the real mild Better's tomato or spaghetti sauce. I said, well, you're welcome. He said, no, I really want to say thank you. I said, well, what's the reason? And she said, I and my father suffer very badly from acid reflux. That's where some of the acid from your stomach gets up into your esophagus. I think I pronounced that incorrectly, but you get the picture. And if it's really bad, and I actually had worked with a colleague at one company who had it so bad he had to have an operation to help fix it. But anyways, they didn't, but they still had it. They said, my father and I love spaghetti sauce because of the acid in there. We have tremendous pain after eating it. Well, by neutralizing some of the acid with what your father's trick was, we didn't have pain when we made our own spaghetti sauce. So thank you. See, acids and bases make a difference. Well, I better get to work. All right, everybody able to read Chapter 14, practice problems, acids and bases on your screen? Thank you, Brianna. All right, these are things you should know for quiz 6. 5 + 1, 6. And first of all, what is an acid per Bronsted theory of acids and base? And that's a proton donor. Now, you don't have to put down H+. You could write proton donor or just H+ donor. All right, what is a base for the Bronsted-Lowry theories of acids and bases? And a base under the Bronsted-Lowry theory of acids and bases is a proton acceptor, H+ acceptor. It accepts it. All right, now, following, you should be able to label the following structures or formulas, really: an acid, base, or salt. Now, A, HCl, hydrochloric acid, it's an acid. B, NaOH, it's a base. Oh, look, C, I hope you all learned by now, sodium chloride. I think I told you, please pass the NaCl, chemists will say. That's your table salt, so it's a salt. Now, H2SO4, it's an acid. And NH3, ammonia, it's a base. And nitric acid, I gave it away, it's an acid. Now, if you look at these for this course, it's not always true, but for this course it is. If it starts with an H, it's an acid. If it starts with an H for this course only, it's an acid. Oh, there's something I forgot on this list or quest problem. All right, your turn. Sodium bicarbonate, which you should know the structure. I just talked about a story, two of them with my father taught me, and that is NaHCO3. Is that an acid, base, or salt? Your turn. And when you're done, give me a thumbs up if you've decided, is that an acid, base, or salt? I see a couple people done. I see just about everybody done. So the answer is, it's a base, and you should know that. All right, let's move on. Now, if the pH of a solution has a hydronium ion concentration of 1.0 times 10 to the minus 3, what is the pH of the solution? And is acidic, basic, sorry, I don't know why this got stuck down here, or neutral. So what are we be trying to find? The pH. What are we given? Hydronium ion concentration, 1.0 times 10 to the minus 3. Important information. Let's see if I still have it up. And I do. You will be given quiz number 6. pH equal hydronium ion concentration. And if hydronium ion concentration is 1.0 times 10 to the minus X, then the pH is X. Therefore, pH equals minus log of hydronium ion concentration. We figured that out because we were given that, put it in, and X is 3. So that's the pH. Now, this you have to learn the pH scale. So pH 7, neutral. Below 7, acidic. Above 7, basic. And I hope you all agree 3 is less than 7, below. So this is acidic solution. And if we do the same thing, hydronium ion concentration is this, trying to find pH. Here's the hydronium. Here's the pH you're given. Put it in there. What's X? 10 to the minus 1.0 times 10 to the minus X. X is 7. Remember, I write my 7 like the Germans and Eastern and Europeans, a lot of them do. And 7 is neutral pH. And finally, what's the solution of the, if a solution has a hydronium ion concentration of 1.0 times 10 to the minus 12, what is the pH of the solution? And is it acidic, basic, or neutral? And we're trying to find the pH. We're given the hydronium ion concentration. pH is minus the log of the hydronium ion concentration. Put it in there. When minus the log of 1.0 times 10 to the minus X, and this is 1.0, which it is, X is the pH. In this case, minus X is minus 12, and X is 12. Now, is that acidic, neutral, or basic? Again, you should memorize. Hold on. Wrong side. Special hint. You should know that the pH scale goes from 0 to 14. At 7, it's neutral. Below 7, it's acidic. Above 7, it's basic. And 12 is above or greater than 7. Therefore, it's basic, which I got that right. Yay, Dr. White. Now, let's look at number 7. If a solution has now OH minus hydroxide ion concentration of 1.0 times 10 to the minus 3, what is the pH of the solution? And is it acidic, basic, or neutral? Now, we're trying to find the pH, and we're given the hydroxide. Wait a second, pH is minus the hydronium. So you need 2 steps. And you've got to remember this. First step, you solve for hydronium ion concentration. How do you do that? Well, you know, hydronium ion concentration times hydroxide equals 1.0 times 10 to the minus 14. And as I mentioned, right before the first quiz, I have cut down on memorization for this class. And notice I'm giving you this an important information. Hydronium ion concentration, H3O plus times hydroxide concentration, OH minus equals 1.0 times 10 to the minus 14. That's where you get it. And that's an important information. Quiz number 6. So now with that information, to get pH, we need the hydronium ion concentration. Therefore, we have to solve for it. Well, how do I get rid of something multiplied by the number I want? I divide by it, because anything divided by itself equals the number 1. How do you like those special effects? Ooh, I can do it at the same time. Anyways, whatever you do to one side, you have to do to the other. So I did that. Hydroxide divided by hydroxide is 1. 1 times hydronium is this. That's equal to 1.0 times 10 to the minus 14 divided by the hydroxide. I figured out the hydroxide. Take this, divided by this, you get 1.0 times 10 to the minus 11 is the hydronium ion concentration. Is that the pH? No, you have to use your second step. Oh, the number 2 fell off. Sorry about that. And remember, pH minus the log of the hydronium. We just calculated that. Put it in there. What's X11 when pH minus the log of 1.0 times 10 to the minus X, when this is 1.0, which will be in my class and quizzes and tests, then the pH is X, in this case, 11. And as I mentioned earlier, you should know this scale. pH 11 is greater than 7, therefore it's basic. Let's do another one, because repetition is good for your grade. If a solution number 9 has a hydroxide ion concentration 1.0 times 10 to the minus 11, what is the pH of the solution? And is it acidic, basic, or neutral? And you're trying to find pH. You're given hydroxide ion concentration of 1.0 times 10 to the minus 11. You need 2 steps. Step 1, you solve for hydronium. Why? Because to calculate the pH, you need minus the log of the hydronium ion concentration, which we don't have. Common mistake, students put the hydroxide in that formula. No, it's different. And now we use hydronium times hydroxide equals 1.0 times 10 to the minus 14. In case you forget, that's important information. Quiz 6. And again, to solve for hydronium, we want to get rid of hydroxide. You divide both sides, or this side, by hydroxide. Whatever you do to one side, you have to do the other, and I do. Anything divided by itself is number 1 times hydronium. Ion concentration is hydronium ion concentration. That's equal to this, 1.0 times 10 to the minus 14 minus hydroxide. Put that number in, which we got when we looked at the problem. Do the math, and we get this number. Is that the pH? No, you have to use the second step, solve for pH. And here you have minus the log of the hydronium ion concentration equals the pH. Put in the hydronium ion concentration, and remember important information, test quiz number 6. If the hydronium ion concentration is 1.0 times 10 to the minus X, and you put it in this formula, then the pH is X. And here, X is 3, so the pH is 3. Is that acidic, basic, or neutral? Remember, pH scale 0 to 14. If it's at 7, it's neutral. Below 7, it's acidic. Well, above 7, it's basic. And for the problem we just did, the pH was 3. Hope we all agree that's less than 7. Therefore, it's acidic. All right, now, if we look at the pH scale, if we add more acid to neutral solution, the pH will drop. It becomes more acidic. I'll say that in slow motion. If we have a water solution at pH 7 and we add acid to it, the pH will become lower because it becomes acidic. So the numerical value gets lower or smaller, decreases. Now, if you have a solution at pH 7 and you add a base to it, you make it basic. And the pH value, numerical value, will increase. How do you like these special effects? So with that in mind, let's look at number 10. And notice I asked not what it becomes, what happens to the numerical value of the pH of a beaker of water at pH equals 7.0 if you add a few drops of concentrated NaOH solution. Well, you have to know NaOH is a base. See how sneaky I am? Testing that. And when you add a base to a neutral solution of water, the pH will increase because it becomes more basic. It will increase. Now, what happens when you add a few drops of H2SO4 to a beaker of water at pH 7.0? Once again, Dr. White's being very sneaky, and I'm testing. First of all, do you know H2SO4 is an acid? Remember, for this class, if it starts in an H, it's an acid other than acetic acid, which I don't ask you to learn the structure. Now, when you add an acid at neutral pH, the pH will drop, get lower, because it's becoming acidic. And if you look at this, I'm asking what happens to the numerical value. It gets lower, or you could put down, as I did, it decreases. Now, let's look at number 11. What happens to the numerical value of pH of a beaker of water, or just a beaker of a buffer solution, if you add a few drops of a dilute acid solution? Well, the key here is buffer solution. And buffer solutions resist change in pH when you add a small amount of acid or base. And because I'm adding a few drops, and the term dilute, you should know, means a small amount, tiny, small amount of acid. That means, because it's a buffer solution, it stays the same. I like those special effects. Not that great. But anyways, now what happens when you add a few drops of a dilute solution? Guess what? The pH stays the same. So for both of these, remember, buffer solution, it resists change in pH when you add a small amount of either an acid or base to it. All right, number 12. Oh, you know what I forgot to put on number 12? 10 points. Oops. Anyways, if you have to add 1.35 times 10 to the third milliliters of a 1.35, 1.53 capital M molarity NaOH solution to neutralize 1.87 times 10 to the second milliliters of an aqueous HCl solution, what is the molarity of the HCl solution? All right, first question, first thing that should be standing out. You're being asked what? What is the molarity of HCl? Remember, molarity, capital M. So we're being asked to find the molarity of HCl in acid. We're given the milliliters and the molarity. Remember, capital M is molarity of an NaOH solution, which is a base. And we're given the milliliters of acid, HCl, that is neutralized. Now, as soon as you see the word neutralize or pH indicator, you know you're dealing with a titration. And important information, quiz 6, hold on, quiz 6, moles of acid for titration at neutralization equals moles of base. And I gave you this formula I developed for monoprotic acid. Milliliters of acid times molarity of acid equals milliliters of base times molarity of base. So what do we know? We're trying to find molarity. We're given the milliliters and the molarity is the sodium hydroxide, a base. We're given the milliliters of acid, that's neutralized. HCl is acid, NaOH a base. At neutralization, moles of acid equal moles of base. And from that, you can derive, which I give to you. Am I nice or what? Don't answer that. But milliliters of acid times molarity of acid equals milliliters of base times molarity of base. Now, what are we trying to find? The molarity of the acid. And I should have had this line over here, not there. Sorry about that. So to get rid of milliliters of acid, I divide this side by milliliters of acid. Whatever we do to one side, we do to the other. And this line should be over here. Don't look, don't look. Oh, it's mistake Monday. Anyways, so this is now milliliters of molarity of acid equals milliliters of base times molarity of base divided by milliliters of acid. In this case, milliliters of base is 1.535 times 10 to the third milliliters. Molarity from here, 1.53 capital M NaOH. We divide by the milliliters of acid HCl, and we get 1.87 times 10 squared. Notice milliliters divide out. We're left with a molarity, even though on this side it says NaOH. And if we look at this, remember on all my quizzes and tests, under your name, it will say, please use proper significant figures for all calculated answers. This is through, I'm in my rut again, 3 significant, 3, 3, rounded off to 3 significant figures. Now I don't have it here, but if you have scientific notation on your calculator, you might have written, you'll see 1.10 times 10 to the first capital M. Well, you won't see the capital M HCl. And that's the molarity. Now let's look at number 13. If you have to add 115 milliliters of a 0.333 capital M read what's on the screen, Dr. White. Capital M did it again. HCl, I got base on the brain today. Capital M, let's try it slowly. HCl, an acid solution. And the key here is to neutralize 211 milliliters of an aqueous NaOH solution. And I could have also written down, to make the indicator change color, what is the molarity of the NaOH solution? So what are we being asked to find? Molarity, capital M, NaOH solution. What are we given? How many milliliters of that NaOH solution we have? What are we also given? How many milliliters of the HCl of this molarity, 0.333 capital M HCl, you use to neutralize it? At neutralization, as soon as you see the term neutralize and you're asked to find the molarity of acid or base, you should know this is a titration. And important information, quiz number 6, I want to say test number 4. When I do it face-to-face, I don't do quizzes as tests, but this would have been part of my test number 4. At neutralization, moles of acid equal moles of base. And that can be further derived into the equation I give you for monoprotic acid, which will always be true in my class, milliliters of acid times molarity of acid equal milliliters of base times molarity of base. And therefore, at neutralization, milliliters of base times molarity of base, I turned them around, but equals milliliters of acid times molarity of acid. Oh, I got it right this time. Well, anyways, molarity of base is what we're trying to find, MnAOH. So to have that alone on one side, to get rid of milliliters of base, I divide by it. Remember, anything divided by itself is the number 1, meaning it's gone. And when you're multiplying and trying to get rid of one numbers, that's what you do. Whatever I do to one side, I do to the other. I divide by milliliters of base. And I did. And milliliters of base divided by milliliters of base equal 1 times molarity of base equals molarity of base. And that's equal to, from up here, milliliters of acid, molarity of acid divided by milliliters of base. We took the time right here to figure that out. Milliliters of hydrochloric acid is 115. The molarity of hydrochloric acid is 0.333, capital M HCl. The molarity of the milliliters to the base is 211. 333, do the math. Our answer is 0.181, 3 significant figures. Remember, when you multiply and divide, you get the same number of significant figures in your answer. Ooh, this is a new one. Poke the answer. Oh, it's awful Monday humor. Anyways, you get the same number of significant figures in your answer as the number you multiply and divide. This is 3, this is 3, this is 3, this is 3. And that would be the molarity of that. Any questions about any of the material on chapter 14 or quiz number 6?
I do.
Go for it, Brianna.
Can I bother you to
It's
walk?
not about, hold on, time out. There's no bother. Nothing's ever wrong in my class when you ask any question. Now, I'm not going to give you my social security number. You can ask it, but I won't. But anything else is fair game.
I promise I won't. Can I
Well,
have
thank
you walk? Can I have you walk through a question like number 8 or 9 or 7?
All right, did I skip that?
No, you did. You did it.
All right, hold on. 7, 8, or 9?
Yeah, but can
All
you,
right, will you,
can I
I,
watch you?
I think I did 7, I did 9, didn't I? Do you want me to do 8 now?
Well, I'm asking like if you can do one like similar, if I
Oh,
can
you
like
want me
watch
to do
you
one
go
live
through
with
it.
different answers?
Yeah,
All right, now you're putting me on the spot. Let's see, where's my whiteboard? I think I closed it. Hold on, I've got to open something. No, it should be up there. Ah, here it is. All right, let's. Gotta get my stylus. Oops. Aren't you glad there's no such thing as a dumb question in my class? I am. I'm glad I learned that lesson. I'm glad I learned how to use this tablet. How would you like me holding up a small whiteboard with my writing up to the camera? Nah. All right, does that help? Is that in the right direction? Give me a thumbs up if it's the answer yes.
yes, thank you.
Well, you're welcome. All right, let's do this. All right, first of all, what are you being asked to find? pH. What are you given? This. And now, if you look at important information, quiz 6, you'll notice pH is minus the log of the hydronium ion concentration, H3O plus. Guess what? We don't have this. So we have to solve or find a way to solve for H3O plus, hydronium ion concentration. And important information, am I nice or what? Don't answer. But anyways, hydronium ion concentration times hydroxide ion concentration equal 1.0 times 10 to the minus 4th. That's called the ionization constant of water, Kw, named after me, I wish. See, I was destined to be a chemist. And now we have that information. So since we don't have, remember, pH equals minus the log of the hydronium ion concentration, we don't have that. So we need 2 steps. And in step 1, you need to solve for the hydronium ion concentration. And you're given the hydroxide. And by knowing that, you know you need to use this. And remember, this is given to you important information. So we want to solve for this. We need to get it alone on one side. Remember, anything divided by anything. Some year I'll use something different than the letter A is equal to 1. So to solve for this, I need it alone on one side. So to get rid of the hydroxide, OH minus, I'll divide by that. And that's because of this. Well, whatever I do to one side, I have to do to the other. So I do. Anything divided by itself becomes number one, is canceled out. Since I want to solve for that, and I know the hydroxide concentration is, I'll put it in. And what was it? 1.0 times 10 to the minus ninth. We figured that out, read the problem. Actually, I don't need, hold on one sec. I don't need that or that or that. And now do the math. And if you have your calculator, this is 14 minus 9, which would be 1.0 times 10 to the minus fifth. Am I done? No, I'm trying to find pH. And pH, you're given important information is this. We've solved for this, but now we have to use this to determine the pH. So we will, and we'll do our second step. Step one was solve for hydronium, which we now have. And where did that 5 go? And now step two, will determine the pH. This is weird. So pH equal minus the log of the hydronium ion concentration. We just figured that right there, so I'll put it in. The number was, I was going to put it in. And remember from important information, quiz number 6, if the hydronium ion concentration is 1.0 times 10 to the minus x, in our case, it's 1.0 times 10 to the minus fifth, therefore x is x. Well, in our case, that would be 5. So here's the pH. Next, we're trying to find out, is it acidic, neutral, or basic? And this you have to learn on yourself and memorize. And that is pH goes from 0 to 14, halfway between 7, that's neutral pH. Above 7 is basic. Below 7 is acidic. And if I look at this number, I hope you all agree that 5 is less than 7, so this is acidic. And again, the key things, read the problem. Determine what are you being asked to find. pH. What are you given? The hydroxide ion concentration, remember in brackets, that's concentration, molarity, is equal to 1.0 times 10 to the minus 9. Because pH equals minus the hydronium ion concentration, we need that number to get pH. We're not given that. Oh, is he mean to us? Whoever wrote this problem. Said, told you it was awful. Humor Monday. That was pretty awful. But anyways, you need 2 steps. First step, solve for hydronium ion concentration. You're given this equation, important information, H3O plus times OH minus 1.0 times 10 to the minus 14. You solve for hydronium H3O plus by dividing both sides by hydroxide. We know what OH is, concentration from up here. So put it in. Are we done? No. This is the hydronium ion concentration. We're trying to get to the pH. So now the second step, we tell pH from important information equals minus the log of the hydronium ion concentration. Put that number in. When this is 1.0 times 10 to the minus x, the pH is x. X is 5, not minus 5. So the pH is 5. And you should know for pH, the scale is 0 to 14. When you go halfway at 7, it's neutral. Below 7 is acidic. Above 7 is basic. Therefore, 5, I hope you all agree, is less than 7, and that's acidic. Does that help?
Yes, thank you.
You're welcome. Like I always say, you never have to apologize or say you're sorry for asking a question in my class or outside of my class, because there's no such thing as a dumb question in my universe. And I say it and I practice it because I know it's true.
Thank you. And then correct me if I'm wrong. I think I figured something out. If you take the 1.0 times 10 to the negative 14 and do the difference, doesn't that give you the answer?
Yep,
Okay,
there's quick ways of doing this.
okay,
I know how to do the quick way, but what I've done this course is shortcuts. You don't really learn what you're doing and you can make easy mistakes. If I show you step by step and more than once, notice how I do things more than once in my class, students learn it, which is why students do well in my class and learn chemistry, because I'm not showing you all sorts of shortcuts throughout the semester. There are a number of things, well, if I do this or that. No, you learn the right way. Plus, I taught you my good friend, my good buddy, unit analysis, which also allows you to know how to do it instead of memorizing, well, in this case, I do this, in this case, I do that. If I look at the clock, oh no, we ran out of time. Time flies when you're having fun with acids, bases, and pH and Dr. White. All right, now, tomorrow we'll go through, it's sad, the last lab of the semester. It's one I wrote. You don't need your kit for it. And I'll also tell you another Dr. White story, which is useful for the rest of your life. And with that, remember Tuesday, I have my office hour at night, 6 to 7:15. Wednesday, I'll be giving quiz 6. And all right, Anna has a question. Let me just finish up. I'll be giving quiz 6. Now, Anna just asked a question about test number 2. I'll talk more about it tomorrow, but for test number 2, you'll have all of next week and into Monday and Tuesday and a finals week to take it. Why? Because I'll probably not pick up test 2 until Wednesday of finals week. That way, when you also take the final, I have to go pick up the scan cards. I only make one trip. Dr. White's lazy. And that gives you an extra time to study if you want. But sometime later this week, starting next Monday, but I'd say hold off. Anna, we have one test and then the final exam. I guess two separate things. Test number 2, the ACS final exam. Does that help?
Yeah, but they are like both the same, or it's like different
No, they're
material?
different.
Different, okay.
Um,
But we can like take them in the one day, like
if you
being,
want, that's why I have it set up that you can take it finals week. My test number 2, I give students 2 hours for. You only need about 45 minutes, but I'll give you 2 hours, all the students. The ACS is a timed final that students in the class have 55 minutes and it's timed. Now, if you're a special needs student for anyone, don't forget when you take my test 2 and when you take the ACS final, bring a copy either printed out or on your cell phone that you can show them your letter from the Center of Access and Accommodations that you get double time. But next week, I would hold off till the end of the week because next week, Monday, Tuesday, and Wednesday, I'm going to review the whole semester. Yep, the whole semester. And that way students get a good review for my test 2 and the ACS final. Plus, I'll give you some hints how to take the ACS final. Okay?
okay, so the final exam, you
You'll
have
have
the
during
file,
finals week, you'll have Monday, Tuesday, and until about 10 o'clock Tuesday morning, 10:30, because I plan about 11 o'clock to be at COD to pick them up.
got it, okay.
Okay? And as I say, no questions are bad questions. All questions are good questions. And with that, I'm going to say I'm done for today. Gang is on. Have a nice rest of the day. Thank you, Brianna. Bye now. I stole that from Granny and the Beverly Hillbillies. Bye. Gang is on.